Afghanistan is a country that's gone through a persistent drought that has taken its toll on the farmers, its economy, and food security. In a bid to find a solution to all this, the Taliban has decided to build what might be the largest artificial river in Asia, the Qosh-Tepa Canal. We're talking about digging a trench about 177 miles long. Now, you may be wondering, how's something this massive being built? Where's this water coming from? What visionary engineering is being used? And most of all, how much of this mega project have they completed? Of all the countries you'd expect to see a mega project, Afghanistan might just be the least likely. The nation's been nothing but a war wreck plagued with violence and poverty for more than 50 years. However, despite all the hardships, they've launched and built a mega project. Furthermore, they do this with zero foreign aid and no engineering advice from any other country. The Qosh-Tepa Canal will be the world's longest and largest artificial irrigation canal. When completed, it'll be 177 miles long, 499 feet wide, and 28 feet deep. Afghanistan's decided to build this mega project in the northern part of their country, extending it from the Amu Darya River. The Qosh-Tepa Canal will start in the province of Balkh and pass through the provinces of Jowzjan before ending in Faryab. At the moment, the Qosh-Tepa Canal is under construction. The contractors are working at a rather fast pace to complete it as soon as possible. And the main motivation for this is the growing water and food shortage crisis across the country. However, as much as this is a great project to help the people of Afghanistan, it has its opposition. For example, other countries that source their water from the Amu Darya River have complained that when the canal is complete, it'll affect their share of the river water. On the other hand, Afghanistan's assured them that such a thing will not happen. Nonetheless, it's the only country that doesn't really benefit from the river water, and thus, it's entitled to its share. To the people of Afghanistan, this canal is quite urgent. You see, this entire area has been more of an arid desert over the past few decades. This has mainly been caused by global warming, declining groundwater reservoirs, and a lack of sufficient irrigation systems. And so, when the canal is completed, an estimated 1 million Afghanis will benefit from the water. This will also enable thousands of farmers to return to agriculture, which will benefit the country. The Taliban plans to achieve this by dedicating 55,000 hectares of land to farms, focusing mainly on grains and wheat. In fact, the government's working towards being a wheat exporter by 2028. The project was initially launched in March 2022, and it's been progressing rather fast since then. It's set to take place in 3 phases. The first and second phases are where the digging of the canal takes place, while the third phase is the installation of water irrigation systems and other infrastructure. But you may be wondering, how is it that a country that's been plagued by war and drought is capable of funding such a mega project? The entire project's being managed by the Afghani National Development Corporation. As for the funding, it's fully funded by the government from tax revenues. The initial budget comes to a total of $500 million, but there's a possibility of adding an extra $100 million after recent reviews. However, with all these funds, Afghanistan's managed to sustain the project and make significant progress with it. This is despite having limited and rather old equipment and limited number of experienced engineers and no outside help. The Qosh-Tepa Canal has been heavily criticized by people and media outlets. Most of them tried to highlight how the Qosh-Tepa Canal is being built and the alleged mistakes, carelessness, and poor engineering methods used. However, when you do some research on your own, you'll realize that it's nothing like that. Before the government gave the green light on the entire project, intensive land surveying and soil studies had been conducted. It wasn't just a matter of sending diggers to carry out such complex operations in a random manner. With these studies, the government could ensure that water lifts were not needed, mainly because of associated costs, flood prevention during the winter, and soil compatibility. So to ensure this, they had to map out the canal on flat land with an elevation similar to that of the source area of the Amu Darya River. In addition, they had to ensure that the canal path was along the most fertile lands and in close proximity to towns and villages along the way. When the government decided on the canal path, they gave the work to 200 private contractors and spread them over 114 sections. This was the beginning of the first phase, which extends about 67 miles. More than 7,000 haul truck and excavator drivers were sent out along with project engineers. And to date, all these people are still working on the project. Not so long ago, they moved to phase 2, which is a distance of 110 miles. Each contractor spreads their excavators in a line, making sure that there's enough space in between for the haul trucks to pass through. The trucks are then filled, and they all leave in an orderly manner to dump their loads in designated low elevation areas. The moment a set of excavators is done digging a section, it's reviewed by the engineers and supervisors. And when all looks good, they move on to the next section and repeat the process. As they do all this, they're guided by detailed maps and specifications. When construction of the canal began, the engineers had to build first 14 hydraulic gates, most of which were topped by a bridge for vehicles. These gates will come in handy in preventing floods during the winter and the heavy rainy periods, as well as when the Amu Darya River levels rise. As the contractors went through the 114 sections, they made sure that each was separated from the other by a few feet of undug dirt. This helped them control the filling process and prevent soil displacement at the banks. This means that the sections were filled slowly. When the first section, which connects the Amu Darya River to the canal, was completed, water was allowed to flow into it. After that, they progressively filled each section by removing the wide dirt walls they left between them. At this point, it's essential to note that the canal's floor and sides are all made of dirt, as the government decided not to use concrete slabs. But depending on which sources you read about this was both a good and bad idea. If you look at it objectively, the idea to not use concrete slabs has great advantages. For example, the lack of concrete slabs means that more eventual natural irrigation will take place to up to about 0.6 miles inland from the canal sides. In addition, there will be higher groundwater reservoir levels, which act as backup water sources when harsh drought kicks in. Apart from all that, there's the issue of money. Installing concrete slabs would have been devastatingly expensive, increasing the budget to more than $1 billion. And if it were to get there, Afghanistan wouldn't have been able to afford it. There were two concrete bridges that were constructed, one for the Hayrat-Balkh Highway and another for the railway. But when building these bridges, the Afghans kept it simple, using a solid reinforced concrete slab design. This mainly involved casting a situ rather than a precast. To ensure they're done with most of the work, some parts of a major network of irrigation pipelines were also integrated with the completed Phase 1 as well as the surrounding area. With these underground irrigation pipelines, farmers who are a few miles away will be able to access water from the canal. Furthermore, other water mains were installed to connect with water pumps in the nearby villages and towns. The canal is already serving its purpose, and those living near the completed Phase 1 are already benefiting from this water. And now, as they work on Phase 2, more people and towns will benefit from it. Initially, the project was expected to be completed in 2028, but with the pace that the contractors are working at, it might just be completed earlier by a year or two. What do you think of the Qosh Tepa Canal? Do you think this visionary build will be successful in turning around the Afghan economy? Digging through the desert, Egypt is creating an artificial river, the largest of its kind. Spanning up to 114 kilometers, this artificial waterway will cater to the needs of the agricultural regions of the new Delta project. The new artificial river will run parallel to the Nile, using recycled water from agricultural drainage water and groundwater. The whole project comes at a cost of $5.25 billion, or 160 billion Egyptian pounds. So, why is Egypt taking such a huge leap when it already has a supply of the longest river in the world, the Nile River? What does this project mean for ordinary citizens already grappling with the effects of inflation? Even though most of the Nile River flows through Egypt, it doesn't mean that it could use all of it. One major reason for this is the Grand Renaissance Dam. The Grand Renaissance Dam is on the Blue Nile tributary in the northern Ethiopian highlands, from where 85% of the Nile's waters flow. The reservoir behind the $4.2 billion dam has a surface area the size of Greater London and has a capacity of 74 billion cubic meters. Since its construction began in 2011, Ethiopia has filled the dam 4 times, limiting the water supply of Egypt. Egypt says the annual share of water has reached 500 cubic meters per person at a time when the United Nations defines water scarcity at 1,000 cubic meters of water per person a year. This has led to a serious conflict between both nations to the extent that the International Crisis Group, an organization that works to prevent wars, warned that armed conflict was possible. Since then, there has been little progress in bridging the gap between both parties. Negotiations spearheaded by the African Union have failed, and all attempts to revive it have gone down the drain. Egyptian Minister of Water Resources, speaking at the 2023 UN Water Conference, warned that this conflict can put an existential danger on 150 million citizens of both Egypt and Sudan. Sudan, with a population of 48 million people, is also heavily reliant on water from the Nile. Egypt has a water deficit of up to 55% of its water needs, which is 120 billion cubic meters. The Western Desert's groundwater and wells are very salty in these areas, and the salinity reaches 10,000 parts per million. This is disastrous for an agricultural-centric country like Egypt, where 50% of the population relies on agriculture as their source of livelihood. It needs water for households and agriculture, especially for growing cotton, which requires a lot of water. Water scarcity has led Egypt to import much of the crops from overseas. In fact, it's the largest importer of wheat, superseded only by China. The Russia-Ukraine war doubled the price of food commodities, leaving Egypt scrambling with a hefty $15 billion food bill. The situation worsened as 80% of Egypt's wheat imports come from both Russia and Ukraine. A treaty from 1929 gave Egypt and Sudan rights to almost all the Nile's water. It also gave them the right to veto projects by countries upstream such as Ethiopia that would deprive them of their share of water. However, Ethiopia considered the old treaties irrelevant in this day and age, and it decided to start building the dam during the Arab Spring when there was political turmoil in Egypt. Moreover, Ethiopia aims to provide clean electricity to its population, 60% of which is without an electrical supply. Climate change is also somewhat to be blamed for this mess. Factors like water scarcity, high temperature, erosion, and saltwater intrusion into freshwater has badly affected most of its fertile lands. During the past 70 years, the country has lost 2.5 million acres of land as a result of desertification and urban expansion. The loss of cultivable soil has increased Egypt's food dependency as it has to import 65% of its basic food needs, while most of the countries in the Nile Basin enjoy growing their own food. Egypt's leading imports are corn, soybeans, wheat, cotton, and vegetable oil. In reality, if not for the water crisis, Egypt would be exporting these items and enjoying millions in profit. The new Delta project isn't just a response to the current situation, but also for securing the future. It's expected that Egypt's population of 107 million will reach 150 million by 2025. So it's not just about today, it's about providing a better future to the upcoming generations. The new Delta is another large-scale national project that aims to enhance Egypt's agricultural capacity. Located west of Alexandria, this project will oversee the cultivation of 2.2 million acres, which constitute a quarter of Egypt's current agricultural land. These crops will rely on surface water sourced from the Rashid branch of the Nile River, as well as the recycled agricultural water brought through the artificial river. The artificial river serves as a path for transferring water from the Al Hammam treatment plant. The Al Hammam treatment plant holds the distinction of being the largest treatment facility globally. In addition to utilizing a portion of the available groundwater, it's a living testament to Egypt's commitment to conserve water resources. It's broken 4 Guinness Book records, boasting an impressive capacity of treating 7.5 million cubic meters per day. The treatment plant provides irrigation for approximately 1.2 million acres of agricultural land west of the Nile Delta area. It'll also remove a significant amount of pollution from Marriott Lake and the Mediterranean seacoast in Alexandria. During the rainy season, it drains and diverts excess water that could contribute to the sinking of lands in Bahira Governorate to the new Delta area. To collect drain water, the government is building 30 water lifting stations that'll collect drain water against the natural slope of the land and triple treat it later on. The cost of the water course, lifting stations, and treatment plant alone is 60 billion Egyptian pounds. The artificial river is an important feat both in terms of construction and purpose. This river will consist of 3 channels constructed in different conditions from the rest of the irrigation channels in Egypt. The river will transport water to desert areas that are more than 100 meters above the Nile River level. But it's not just about land reformation and water. To put Egypt on a global stage in terms of agricultural produce, it needs supporting infrastructure. For this purpose, the government has launched the Mustaqbal Egypt project, which is located within the area of the new Delta project. It aims to develop the northwestern coast region through the establishment of new urban and agricultural communities characterized by an appropriate administrative system. Industrial complexes will be constructed based on full-fledged agricultural production and harvesting with the latest mechanisms, then sorting, packaging, and manufacturing. Under its umbrella, roads, underground water wells, and 2 power stations of 350 megawatts will be introduced. Moreover, Mustaqbal Egypt will also include residential, administrative buildings, and warehouses for storing agricultural produce. The target is to reclaim 500,000 acres of land, out of which 200,000 acres are already reclaimed. By doing this, Egypt is bridging the agricultural gap at the local level to provide high-quality agricultural products at reasonable prices for citizens and to export the surplus abroad. For a nation already struggling with inflation, this would be a blessing in disguise. In September 2023, Egypt's inflation rate reached an all-time high of 38%, making it difficult for the average citizen to purchase necessities such as food, clothing, and shelter. The project's proximity to the Sphinx and Burj Al Arab airports and the ports of Decatur and Alexandria will facilitate the delivery of goods and make it an attractive destination for investors. The cultivated land will rely on the artificial river for irrigation purposes. The first channel of the river is 42 kilometers long, including 26 kilometers of pipes and 16 kilometers of open channels to transport about 10 million cubic meters from the Rashid branch within the Mustaqbal Egypt project. The second channel extends about 170 meters from Hammam Station to transfer 7 million cubic meters per day to the south of Daba'a. The third channel consists of 2 pipelines that will carry recycled water from southern and western wastewater treatment and desalinization plants. Through these initiatives, Egypt's agricultural ministry aims to strengthen food security, reduce the import gap of strategic commodities, and support activities related to agriculture such as livestock and poultry. The new delta will not only establish agricultural and industrial complexes, but also link agriculture, manufacturing industry, and trade. The production of commercially valuable crops like wheat and corn, vegetable, fruits, and industrial crops is expected to increase by 10 to 15%. Right now, Saudi Arabia is facing a colossal problem. It's the 12th largest country by size with no lakes or rivers and very little rainfall. With the groundwater resource almost finished, scientists have warned that the kingdom may run out of water within some decades. To curb this problem, Saudi Arabia has launched many initiatives from time to time that include recycling wastewater for landscaping and fodder production and encouraging citizens to use less water. But that by itself will not solve the problem completely. That's why they've planned to build an artificial river that even surpasses the length of the Nile River. This artificial river will use pipes set underground, with each pipe having a diameter of 7.3 feet. The whole network will be 7,400 miles in length, almost twice that of the Nile River. Almost 90% of Saudi Arabia is desert with no surface water resources. The growing population of 36 million needs access to clean, drinkable water, as KSA has one of the highest rates of water consumption in the world. Currently, Saudi Arabia has 2 resources for water: desalinated water coming out of the Red Sea and groundwater, also known as non-renewable fossil groundwater. As of 2019, 60% of the country's water comes from desalination, while less than 40% is contributed by the groundwater. By far, the agricultural sector is the largest consumer of fresh water, accounting for 67% of consumption, which is satisfied by the groundwater. Due to the arid conditions of the land, agriculture only meets a third of the food demand, while the rest is imported. Since the 1950s, the country's relied on treated seawater and has since come to be the leading desalinated water producer in the world, with 7.6 million cubic meters produced daily. As of October 2020, Saudi Arabia has 33 desalination plants in 17 locations run by the Saline Water Conversion Corporation, SWCC. This corporation is a government-run agency responsible for producing 20% of the global desalinated water. Most of the desalination plants are spread across the west coast near the Red Sea, while very few are located on the east side. 99.9% of the water for Jeddah, Taif, and Makkah comes from the sea that is still relatively near the coast. But what about the places that are far from the sea? How do they get their water? Saudi Arabia has laid out a neat but vast network of pipelines across the desert so that every person has access to potable water. The length of these existing pipes under the Saudi cities is 78,200 miles and transports 9.4 million cubic meters of water produced each day. If this water was equally distributed to the world's population, each person would receive 2 bottles of clean water daily. The artificial river pipeline would be another valuable addition to this already impressive network. To put this into perspective, the pipes plus the river, if laid end to end, can circle the world 3 times. The project will utilize anti-corrosion pipes made in KSA to support the local economy. The pipes are placed in 13-foot deep ground with a width of 36 feet and will transport the treated water from the desalination plant. The waters of the Red Sea and the Arabian Gulf are saltier than the other seas, so it takes more effort to remove this salt and convert it into a drinkable version. But what's truly impressive is that they can do it with less energy. In the past, 4 kilowatt hours of energy was needed to desalinate 1 cubic meter of water. Now it takes 2.5 to 3 kilowatt hours to create the same amount. One Saudi plant even set a record of using only 2.27 kilowatt hours to treat 1 cubic meter of water. The amount of energy consumed depends on the type of desalination technology used. This brings us to 2 methods of desalination used worldwide. One is reverse osmosis and the other is thermal desalination. You might have heard the term RO water purifier, RO plant, and so on. RO stands for reverse osmosis. In simple terms, you take the seawater on one side and pressure it to pass through a membrane. This membrane removes ions, unwanted molecules, and larger particles, leaving behind fresh water, which is pumped to homes. Another technique uses heat to separate fresh water from seawater. This is known as thermal desalination, but its major drawback is that it's an energy-intensive process and also pollutes the environment with its CO2 emissions. In the past, Saudi Arabia was relying on thermal desalination, but ever since switching to RO, they've slashed their fuel usage by 80% and made CO2 emissions non-existent. However, a disadvantage of desalination is the remaining water, also called brine. This brine is heavily loaded with salt particles removed from the freshwater. It's often released to the sea, causing coastal waters to get even saltier. It's important to note here that the desalination alone won't meet future water demand. As a result, Saudi Arabia has taken several measures to reduce consumption by increasing efficiency, eliminating waste, and ending unsustainable practices. In the 1970s, as the agricultural sector boomed, so did the water consumption. Aquifer or underground water was used to meet this demand. The government undertook an important effort to map such aquifers to then drill wells for urban and agricultural use. In the image, the colored portions show you the aquifers underneath the Saudi soil. Those aquifers remained undisturbed till the 1980s, as there were fewer mechanical resources and the money to tap into them. But how could there be water beneath a desert? Well, it's because this groundwater was formed millions of years ago, sitting at a depth of 300 to 1,600 feet. At that time, the land and climate of the region could have been different. The country's agricultural development over the last 3 decades resulted in phenomenal growth in the production of basic foods. Vast tracts of the desert have been transformed into fertile farmland, creating a huge demand for water resources. Aerial images of the Saudi landscape show nowadays green farm fields thanks to irrigation. In fact, we have a video on how Saudi Arabia is transforming its desert into a green oasis, so do check that out if you can. The agricultural boom of Saudi Arabia was only possible due to government subsidies for desert irrigation. Otherwise, the cost of farming crops in a desert would be astronomical in comparison to importing them. Today, the country exports several foodstuffs like wheat, dates, dairy products, eggs, fish, poultry, vegetables, and flowers to markets around the world. However, the unsustainable use of groundwater neatly depleted all the aquifer water. This led the Saudi government to end subsidies in 2016 for water-intensive crops to discourage agricultural water use. Under the Saudi vision for 2030, a national water conservation plan was launched named Qatra, which is Arabic for droplet. Through the program, the ministry aimed to reduce daily per capita consumption from 263 liters to 150 liters by 2030. But the issue of saving water is beyond just making laws. The attitude of the 36 million population of the country is equally important, if not more. A study in 2023 showed that over half the participants agree that water must be conserved, but 3/4 disagree that they're obliged to conserve water. An example of where this has been successful is in California. Severe drought caused many farmers to use natural groundwater, which satisfied almost 60% of the demand. However, the pumping has been largely unregulated, resulting in a serious decline in the California aquifers. This prompted Californians to change their behaviors along with the development of new technologies and devices that optimize water use. This led to an amazing reduction in water use of almost 25%. Saudi Arabia can use California as an example of how to deal with this problem. Saudi Arabia does not have an immediate water crisis, so they still have time to plan. They have a strong community system that helps unite people. This unity can transform into a positive collective action to save a crucial resource for the upcoming generations. Despite the concern 97% of the Saudis have access to drinkable water, the creation of the artificial river will enhance this number even more. To increase the private sector's participation and diversify its revenue, KSA aims to increase the number of desalinated plants owned by the private sector. The eventual goal of Vision 2030's water sector privatization is to raise as much as $200 billion through privatization and private-public partnerships. This will not only create thousands of jobs, but also assist Saudi Arabia in shifting its dependency on oil revenue. The water scarcity isn't unique to Saudi Arabia. Other countries like Egypt are also tackling it. In a similar fashion, Egypt's planning to build an artificial river stretching up to 108 miles for $5.2 billion. This river is designed to cultivate more than 3,500 square miles, utilizing water from the treatment facility and some portion of the groundwater. In the same way, Afghanistan is also building an artificial river called the Qosh Tepa Canal to irrigate its dry northern plains. Perhaps we'll be seeing more and more water-starved countries adopt this pattern in the future. As Israel continues its focus on Gaza, there are talks of reviving the controversial Ben Gurion Canal, a potential rival to the Suez Canal. Proposed in the 1960s by Israel, the canal aims to connect the Mediterranean Sea with the Red Sea using the southern end of the Gulf of Aqaba. Now, there's already a connection between the two seas in the form of the Suez Canal that opened to the world in 1868. For those who don't know, the Suez Canal is an artificial sea level waterway in Egypt that offers vessels a direct route between the North Atlantic and the Northern Indian Oceans, saving 7 to 10 days worth of a sea journey. It provides the shortest sea route between Asia and Europe and currently handles 12% of the world's trade. There's no doubt that the Suez Canal is the centerpiece of the Egyptian economy, contributing 2% of the country. Its significance was enhanced after the Chilean expansion, which further increased its capacity for maritime traffic. Russia's war on Ukraine further increased tanker traffic, and the Suez Canal transit fee rose by 15%. The current transit fee of $700,000 increased to $805,000. The Ben Gurion Canal, if constructed, would rival the Suez Canal and cause a major financial threat to Egypt. Its canal is going to be 1/3 longer than the 120-mile Suez Canal and could potentially give Israel a monopoly over the global supply routes for oil, grain, and shipping. The route of the proposed canal starts from the mouth of the Gulf of Aqaba through the port city of Eilat. It then traverses the Araba Valley for about 62 miles between the Negev Mountains and the Jordanian highlands, passing the Dead Sea Basin along the way. It then turns a sharp northward direction to circumvent the Gaza Strip and connect to the Mediterranean Sea. In this way, the Ben Gurion Canal can link the three water bodies: the Red Sea, the Dead Sea, and the Mediterranean. As 70% of Gaza's home and half of the buildings have been reduced to rubble, there are speculations that the canal might go straight through the region instead of a long detour around it. This would be a more direct and cheaper connection than the original route, but the only obstacle in the way is the thousands of Palestinians residing in the territory. The canal is named after David Ben Gurion, the founding father and the first prime minister of Israel. At 164 feet deep and 650 feet wide, it would be capable of accommodating the world's biggest ships, an advantage over the more limited Suez Canal. Unlike the Suez Canal with its sandy shores, the Israeli rival would have featured rock walls that would reduce maintenance requirements to a minimum. Not to mention that its 181-mile length exceeds Suez by a third. Moreover, the Suez Canal has been blocked multiple times in the past, threatening Israel's maritime trade. Hence, this alternate route would be a blessing in disguise for the country. Around 300,000 workers would be needed to complete the project, and will cost anywhere from $55 to $100 billion. Israel's expected to earn around $6 billion annually in transit fees, deeply cutting into Egypt's revenues, which reached a record $9.4 billion in fiscal year 22 to 23. Now, the idea for this canal has been around for a long time, but it re-emerged after the Abrahamic Accords between Israel, Morocco, Bahrain, and UAE. In a nutshell, the participant countries vowed to maintain peace in the Middle East and live with mutual dignity. In March 2021, the Suez Canal was blocked for 6 days after a colossal container ship crashed into a bank of a single-lane stretch. The vessel was the size of 4 football pitches and became wedged between the Suez Canal. The blockage disturbed the delivery of over $9 billion worth of goods each day, which is equivalent to $400 million worth of trade each hour. Since it had been stuck for over 6 days, approximately $54 billion had been lost. This incident nearly brought the global chain to its knees and paved the way for an alternative to be considered. Just a month after that, Israel stated that they'd start this project in June 2021. This, of course, has not been successfully implemented, and many analysts point towards the existence of the Gaza Strip as one of the main reasons. But who knows, maybe in the future Israel will decide to realize this project after all. Okay, we've heard the plan, but where did it all start? The earliest evidence linking the Ben Gurion Canal is through a classified U.S. document. U.S. Lawrence Livermore Laboratory developed the concept of building this transoceanic canal using nuclear bombs. The document was declassified back in 1993 and revealed the U.S. planned to use 520 nuclear bombs. Yes, that's correct. 520 nuclear bombs were going to be used to carve out the waterway. The memo called for the use of nuclear explosives for the excavation of the Dead Sea Canal across the Negev Desert. As part of the pricing model, the memorandum estimated that 4 megaton devices would be needed for every mile. Other methods of excavation were deemed expensive for the construction of the canal. The document also noted that while it's a valuable alternative to the present Suez, the neighboring Arab countries of Israel will strongly oppose the project. At the moment, cargo ships continue using the Suez route even though attacks by the Houthi rebels cut down freight traffic by 45%. Since the Suez is such an important waterway, its closure can make or break the market. And this isn't the first time the Suez Canal has been closed. In fact, there's a list of events in which this has happened. 1858 saw a French Suez Canal company being formed to build the canal with a 99-year lease. A decade after that, the Suez was open to the world with a lot of fanfare and delight. After all, it saved ships a long detour through the coast of South Africa to reach the European nations. Afterwards, the Suez Company came under French-British ownership after the UK bought 44% of the shares. In 1888, European nations signed the Constantinople International Convention, which guaranteed the right of passage via the Suez Canal to all ships, even during times of war and peace. However, this treaty was ignored after Egyptian President Abdel Nasser came to power. He nationalized the canal in 1956, which gave Egypt a monopoly over maritime traffic. Egypt closed off access to the canal on several occasions following the establishment of Israel in 1948. Egypt blocked Israeli vessels from accessing the canal from 1948 till 1950, affecting its ability to trade with the world. With tensions high on both sides and Israel's desire to access the coveted path, a war broke out called the Tripartite Aggression. Britain and France secretly partnered with Israel and staged a military attack on the Suez Canal. In response, Egypt closed the canal to all international shipping the same year, sparking one of the biggest trade disruptions ever in maritime history. Intervention forced by U.S. President Dwight Eisenhower forced him to concede, but the canal was blocked to Israeli traffic for a year. But wait, that's not all. The canal was once again closed for a staggering 8-year period in 1967 at the beginning of the Six-Day War. Also known as the Arab-Israeli War, it was fought between Israel and a coalition of Arab states, primarily Egypt, Syria, and Jordan. During this conflict, all the land trade routes were blocked by Arab states, further hampering Israel's ability to trade with East Africa and Asia, and import oil from the Gulf region. This further solidified Israel's resolve to have an independent connection between the Red Sea and the Mediterranean. Not to mention that the Ben Gurion Canal would have the full backing of the U.S. and other Western countries like the United Kingdom, as they have a friendly relationship with Israel. This would ensure that Egypt and other Arab nations no longer use the Suez Canal or the Straits of Tiran as leverage against its estranged neighbor. However, times have changed, and many Arab countries have normalized their relations with Israel. This includes the UAE at the forefront, followed by Saudi Arabia, Morocco, Bahrain, and Sudan. As evidence of this is the announcement of the India-Middle East Corridor. In September 2023, the leaders of Saudi Arabia, UAE, India, and the USA met in the Indian capital of New Delhi for the G20 summit. Under the proposed corridor, a transportation link will be established from India to Europe across the Arabian Peninsula via Dubai and the UAE to the Israel port of Haifa. It will supplement existing road and maritime transport routes, aiming to increase connectivity and economic integration between Asia and Europe via energy structure, railways, high-speed cables, and shipping lanes. The participating countries constitute 40% of the world's population and roughly half the global economy. This corridor will rely on the UAE and Saudi Arabia's seaports, roads, and logistics hubs, serving to strengthen these Gulf Arab states' importance as critical nodes in global trade routes. With this backdrop, the Ben Gurion Canal is not a far stretch and can be seen as a possibility in the future. Do you think Israel will build it? Share your thoughts in the comments. We put a lot of thought and effort into each video. By liking, subscribing, and sharing, you show your support to Visionary Builds. We are committed to releasing you 2 videos to watch each week, and your support means a lot. Thanks for watching.